Hi, what's going on? This is the 8th video of our GIS lab lesson tutorial. In this video, we are going to be creating shapefiles and also create attribute data table for those shapefiles. So, before we continue, let me first of all tell you that we are going to be creating shapefiles using 3 basic methods. The first one, we are going to use a CSV file to create a shapefile and also to create attribute table for it. However, we have done that in our previous video where we added these students' CSV file and later converted it to a shapefile. So basically, that's how to create a shapefile using the CSV file. But I will still run over it in this video. Then the second method we are going to use is plotting the shapefile using coordinates. Thus, you have the coordinates of points, either points, polygons, or lines. You can use Phantom GIS to plot the points, and in that process, create a shapefile for them. Then, the last but not the least method we are going to use is the digitizing method. However, I will not be covering that method in detail in this video. We have a separate video that focus on digitizing. So, but I'm going to create shapefiles that you're going to use for that digitizing in the next video. So now, let's start with the first method. Let's go to our local disk, open our GIS project folder, and then inside the others folder, we have this Nasarawa town coordinates. Open it. If you can remember, in the last video, I told you that under the coordinates of the control points, we have something called use this verify your work. So these are actually coordinates picked on our project area, just for us to use and verify our georeferencing work. So I'm going to use these coordinates to create a shapefile, and in that process, verify our georeferencing work. So now, in order for us to do that, if you look at the first point, is described as state locus junction. So this is actually a junction somewhere on our raster data. The junction is somewhere on our raster data, and the place is called state locus. Then the second point is oversea junction. This is also a road junction on our raster data, and that junction is called oversea. And then we have the last point, which is the closest riverside to the road. So closest riverside to the road, we have the road, and then we have the riverside. So probably this is where that point is talking about. Let me zoom in closely. Probably this is the point we are talking about in this third point. So we will see very soon. So in order for us to use either CSV or plotting method to create shapefile for this point, we will have to proceed as follows. First, let me explain the process of creating shapefiles using the CSV file. So remember that the CSV file is called the comma separated variable file, and you can easily create it from the Excel program. So when you open up the Excel program, inside of it, you type in all the controls. That's the coordinates of the controls, including the description and then maybe the pointing. So let's start by typing the titles. So the first one will be point ID. Then the second column will have to be our eastings. Then the third column will be margins. Then the fourth column will be maybe point description. So you can actually name it whatever you want to name it. I'm just using this as an example. So let's stop here. Let's assume these are going to be the titles of our field. Then here we have point 1, 2, 3. I think the points are only 3. Yes, 1, 2, 3. So now we'll copy the point description, or let's start with the eastings first. I'll first of all copy the easting for the first point, paste it there. Then go ahead and copy the northern for the first point, paste it there. Then go ahead and copy the point description, all for the first point, and then paste it there. Repeat the same thing for the remaining 2 points. So now we have finished copying and pasting all the data for the 3 control points. So now the next thing we'll do is to save this particular file as a CSV file. That's command separated variable file. So you go to your file, then save as. Then navigate to wherever you want to save your project. This time around, I'm going to save it inside my others folder, since it's actually going to be a CSV file. So I'm going to name it control verification. Then I'm going to select the save as type as CSV. This is very important. If you did not select this option, then it means your file will not be saved as CSV. So as you can see, the other CSV file is appearing inside our others folder on our C drive. So click on save to save it as a CSV file. Make sure that save as type is CSV, command eliminated. So click on save. Okay. So now we are done with this. So you can minimize it. Then go back to your Quantum GIS. So here now you can now plot that particular CSV file as a CSV file, and then later on you convert it to a shapefile, just the way we did in the previous video for this student's CSV file. So that is how to go about that. So let's quickly do that. So go to your layer menu, go to add the related text layer, then click on browse, then navigate to your C drive, go to your GIS project folder, others folder, and then select control verification. So click on open, then make sure tab and comma are selected so that you have the preview of your data, just like this. So remember that X field is for easting and Y field is for northern. So make sure you select the correct options. Y for northern. So having done this, then you can now click on OK. When you click on OK, your controls will be plotted on the point. So now let's zoom to extent. So as you can see, we have our control verification here, here, and here, 3 of them. 1, 2, 3. So here we go, we have them. And based on the decision we have for each of the points, I think our georeferencing is 95% accurate. You can see the first point is saying state locus junction, and then this is overseas junction, and then this is the closest site to the river. So we have 2 junctions. This is the junction, this is state locus junction, and this is the overseas junction, and then this is the closest site to the river. So we have our points falling approximately in the expected location. So our georeferencing is at least 90% or 95% accurate. This is the third point. So if you are still doubting what I'm saying, let me label the points so that you see it for yourself. So double click or right click on the control verification layer and then go to properties. So from the properties dialog box, go to the label tab layer, label tab, then select display label. Then from the field containing label, choose point description. Then you can now click on OK to apply. So here we go. These are the point description, as you can see. These are the point description. If you cannot see them, let me off the raster layer so that you can see it clearly. Zoom to layer extent, and you can see them. So here we have our 3 control points falling approximately in the expected location. So I can go back and then off the label. Apply OK. So we are not done yet. This is still a CSV file. We need to convert it to a shapefile. So to convert it to a shapefile is very simple. You just right click on it and then go to Save As. So from the Save As, you make sure the format is set to ESRI shapefile. Then Save As, where you want to, the location where you want to save it. Click on Browse to select the location where you want to save it. So remember that we are saving all our shapefiles in our GIS folder inside the vectors folder. So I'm going to save this particular shapefile inside the Nasarawa shapefiles folder. And remember, we have one shapefile already called students. That is this. So we're going to have a second shapefile called control verification. So I'll name it control verification. So I'll click on save. Then the layer, coordinate reference system. These options are okay. I can type the data source decision if I wish. I can type a decision for the, or a note for the layer if I wish. Then I will add it to the layer panel. Immediately the conversion is completed. So I'll click on OK. So export to vector layer has been completed. So okay. So here is our vector layer. As you can see, here is our vector layer. While this is the CSV layer. So let me remove the CSV layer. Remove the CSV layer, and then we have our vector layer. So the vector layer, the CSV layer has been converted into a vector layer. So now this is how to create a shapefile from a CSV data. So now, how about the attributes? Here, this point description is an attribute. Point ID is also an attribute. So automatically, using this method, automatically your point will have attributes. The shapefile will have attributes attached to it. So in order for you to see the attribute, what you do is to right click and then select Open Attribute Table. So when you open up the attribute table, you see that all your data are there in the attribute table. So you don't have to start creating attribute table from scratch, just like in other methods. That's one advantage of creating shapefile from CSV data. And in fact, I love this method better than others. However, it depends on the availability of data. If you don't have the coordinate set, then you may not be able to use the CSV file method. So now, how about creating shapefile from by plotting the coordinates of points? This is also a simple thing to do. So, but I'm not going to cover it in detail in this video because right now I don't have set of coordinates to practicalize it. But I'm going to show you the approach, and then if you have your set of coordinates, you can follow what I show you, and then you will get it done. So, in order for you to convert, to plot, or to create shapefiles from or by plotting coordinates, what you do is to simply select the shapefile you want to create, you want to edit. Then go to the layer menu, then select toggle edit. So after which, you note that a pen indicating that the layer is under toggle editing is indicated here. So after which you now go to your edit menu and then click on add feature. From the edit menu, you click on add feature. So with the layer selected, you will now go to wherever you want to add the point and then click once. When you click once, it will bring out a dialog box where you are going to add up the attribute data. So if you have your attribute data, you just add it up. So I think we have 3 points here. So the next point ID is going to be 4. Then if you have your instance value and nothing value, you type them. I don't have one, but I'm just showing you a typical example of what to do. Then point description. If you want to add it, you also add it something like a road junction. So then you click on OK to add the point. Now you see that the point has been added somewhere here. So if you want to add more points, you click where you want to add the point to add it. So if you right click and open the attribute table, you see that you now have 4 data. And this is the new point we just added, called road junction. And then it has the point ID 4. Here we go, is it. So as you add more points using this method, it will continue, your attribute data will continue to build up. So this is one way of using plotting method to add coordinates. How about if you have the set of coordinates in the form of these instance and models, and then you want to plot it directly on your Quantum GIS map interface? What you do is to use these particular options called numeric digitize. So by clicking on the numeric digitize, it will bring out a dialog box where you are going to add the coordinates of those digits, of those points. So double click here and then type in your coordinates. That's the instance for X. Then type in the coordinate for Y. After which you now select where your coordinates are located. The coordinates, are they in the CRS view of the project, or they are in the CRS, that's the coordinate reference system of the layer? So select whichever option that match your data, and then you click on OK. So this is how to plot coordinates if you have them. I told you that I will not do this in detail because I don't have a set of coordinates. So if you have more than one point, you do for the next, and then by the time you type something here, you have something here, you will have the third point automatically. You type the easting, type the nodding, you have the fourth point automatically. So continuously. By the time you have finished adding the points, then you click on OK. It will plot all the points for you at once. So this is how to go about creating shapefiles using plotting of coordinates. So the next method we are going to use to create shapefile is the digitizing method. So in the digitizing method, you need to create shapefiles, whether point shapefiles or polygon shapefiles or line shapefiles. So take a look at our raster data. We have so many features. We have structures in the form of polygons. We have roads in the form of lines, and then in some places we have things like trees in the form of points, and so on. So now, assuming you want to create shapefile for points representing these trees, and then for lines representing the roads and the streams, and then maybe polygon shapefile for structures, buildings, and so on. How are you going to go about it? So far so good. We have seen how to create point shapefile. The two shapefiles we have not created so far are lines and polygon shapefiles. So now let's go about creating line shapefiles. Now, how do you create line shapefile for roads and other linear features? You go to your layer menu, and then go to new, then select new shapefile. So from the new shapefile dialog box, the type of shapefile we are going to create is 9. We have created point shapefile using CSV method and plotting of coordinate method. So let's not bother ourselves by creating more point shapefile. Let's go to creating line shapefile first, and then polygon shapefile. Then if you have more time, we can come back to creating the point shapefile. So select the type of shapefile you want to create. Let me start with the line shapefile first. So when you select it, then you select the coordinate reference system if this is not what you are going to use. So, but this is what I'm going to use, so I don't need to specify any coordinate reference system. So I'm going to type in the attributes name. How many attributes am I going to use? This line is going to be for the roads. So what attribute am I going to use? So the roads, I will have something like location of the roads as an attribute. So location as an attribute. The location field is going to be a text data. So I'll select text data. The width 80 is okay. Then I'll click on add. If I have more attribute to create, I'll click on add to attribute list, and then it will add it here. So I've added one attribute list. So let me add a second attribute list, maybe street name. The name of the street is also going to be a text data. So I'll click on add to add it to the attribute list. Then the next is going to be maybe street distance, and this time around is going to be a whole number, or let me use decimal. You can have decimal points, decimal place. So let me use decimal as the field type. So I'll click on add to list. So if you have any amount of attribute you want to add, this is how to go about it. You type in the name of the attribute field, and then select the type, then you add to the attribute list. So if you are satisfied, then you click on OK. So if you click on OK, Quantum GIS will take you to where you are going to save the attribute. So this time around, I would like to save the attribute inside my C drive, inside the GIS project folder, and then inside the vector folder, then inside of the Nasarawa shapefile folder. So as you can see, we have other folders there, other shapefiles there. So we are going to have our third shapefile called street. So the shapefile is street. The encoding type is UTF-8. That's just fine. So I'll click on save. So as you can see, the attribute has been, the shapefile has been created and added to my layer panel as street. So if you go back to your folder, to our vector folder where we saved the shapefile, you see that we have more shapefiles there right now. So just as you can see, we have the street shapefile, we have the control verification shapefile, and then we have the student shapefile we created earlier in the previous video. So this is how to create a shapefile, a line shapefile. So now let's create the polygon shapefile. So you do the same thing. Go to the layer menu, new shapefile. Then you select polygon in the type. If you want to change the coordinate reference system, you specify it by clicking on this button. So if you want to add names of attribute data for your shapefile, you can easily do so. So this shapefile are going to be the buildings, for the buildings on our raster data. So I'll simply type maybe buildings name, building name as the name of my attributes, one of my attributes. Then I'll click on add to list. It's going to be, the type is text data. So I wouldn't mind changing it. I'll click on add to list. Then the next attribute I'm going to use is maybe the size of the building in terms of area. Let me type building size. add to list. Sorry, building size, I made a mistake. Building size is going to be a numeric field, not a string. So I'll select it and remove. So I'll go back and type building size. The type is going to be a decimal number, and then I'll add it to the list. So if I have other attributes, I can type them. Maybe building purpose, the purpose of the building. This time around is going to be a text data, so I'll add it to list. So this field will be either if the building is commercial, residential, or whatever. That's the attribute for this field. That's the field type for this attribute. So if I'm satisfied, I will now click on OK. And note that we are creating a Polygon shapefile for buildings. So I'll click on OK, and then it will take me to wherever I want to save it. I will navigate to my C drive, inside my GIS project folder, inside the vectors folder, and then inside the Nasarawa shapefile folder. Then I'll select, I will now type in the name of the shapefile as buildings. Then I can now save it. So as you can see, I now have additional shapefile on my layer panel called building. So if you go back to our folder, you will see that we have additional shapefile called building. So we have successfully created the Polygon shapefile called building. So if I wish to create another shapefile, maybe for points, for trees, I will easily do so by going to the layer menu, new shapefile. Then I'll make sure that point is selected. Coordinate system WGS 1984 is okay. I don't need to change it. So I want to add attribute field. Maybe since I'm doing for trees, maybe the tree, the height of the tree, tree height is going to be text data. So I'll add it to the list. Then maybe the age of the tree age as my attribute is going to be text data. I'll add it to the field. Sorry, height should be a numeric data, not string data or text data. So I will remove it and re-add it. Tree height is going to be a numeric data. So I'll add to list. So if you have more attribute to add, you continue to type the name of the attribute field and then select the attribute type and then add it to list. So I'll click on OK to save my shapefile. I will navigate to my folder where I want to save my shapefile, vectors folder, Nasarawa shapefile, and then I will type in the name of the shapefile, trees. So I'll click on OK, and then it will add it off to my layer panel as a shapefile. So now we have successfully created shapefiles, both for points, lines, and for polygons. So if you have more features to digitize or to represent using shapefile, this is how to go about creating them. Now, these shapefiles are currently empty. So if I right click on the tree shapefile and open the attribute table for the trees, you see that the attribute data is currently empty. And then as you can see, we have the ID of the field, we have the age field, and then we have the tree field for our attribute table, tree height field for our attribute table. So the same thing too is applicable to the building. It's empty. If I open the attribute table, we have the ID, field ID, we have the building name ID, building size ID, building purpose ID, but the fields are empty. So the same thing is applicable to the streets. If I right click and open the attribute field, attribute table, it will be empty. So for us to add data to this field, we are going to use digitizing method to add data to these shapefiles. Unlike this shapefile where we are able to add data directly from the CSV file, in this ones we are going to be adding using the digitizing method. So I'm going to cover the digitizing method in detail in the next video. If you open the attribute for the students, you see that it is well populated. We have the surname field, name field, other name field, phone number field, email field, and so on. So all of this and this were populated using the CSV file method of creating shapefile. So for this and this, we are going to use the digitizing method to populate or to add content to the shapefiles. So I hope you understood the concept of creating shapefile in QGIS. So in the next video, we are going to add content to the shapefiles we created using the layer new shapefile method. Thus, we are going to use the digitizing method to add or create more content in our shapefile. So till then, I wish you the very best. Have a nice day.